Okay, so now this is where it gets a little weird. We're about to throw some variables in there. If there is not a sign in front of the radical, it's an understood positive. So this one's not bad. What's the positive square root of 25? 5. Over here, I've always told you that a square root and a square will cancel out, which will give you x. But I wanted the positive solution, and I don't know what x is, but to guarantee that I get the positive solution, I'm going to put absolute value around it. Now over here, I can rewrite this as x squared squared. And now I've got my square root and this outside exponent are going to cancel each other out. So I just get x squared. But I don't need absolute value on this one because x could be negative, but once you square it, it becomes positive. So absolute value is not necessary on that one. So here's the deal. You're going to need absolute value when you have an even root and an odd power in the answer. And that's the only time you have to put absolute value in there. If you have an even root and an odd power in the answer. So we're going to try to simplify some of these. Now over here it's asking for positive or negative, so we can include positive and negative. Square root of 16. Now 16 is the same thing as 4 squared, and x to the 6 is the same thing as x to the third to the second, knowing my properties of exponents. So now the square root of 4 squared is 4, and the square root of x cubed squared is x cubed. And because it said positive or negative, I don't need absolute value, because that means I could have positive or negative. But now let's see this one. It's asking for a fifth root, so that's an odd index. I don't need to worry about absolute value. But I don't know what the fifth root of 243 is, but I'm betting that it's divisible by 3. So 243 divisible by 3 is what? I don't know. So with 3, that's going to be 81. Okay. 81 is 9 times 9. Each one of those is 3 times 3. So, ooh, do I have a perfect fifth root? Yikes. 1, 2, 3, 4, 5. Look at that. I didn't know that. Okay. So 3 to the 5th, and then I'm going to rewrite a to the 10th as a squared to the 5th. Oh, my eraser's not working. A squared to the 5th. So notice I'm wanting my outside exponent to match this index. And then b to the 15th I'm going to rewrite as b to the 3rd to the 5th, so that I can get all those exponents and radicals to cancel out. So I'm going to get 3a squared b cubed. And remember, I don't need absolute value on any of these because it was an odd index or an odd root. So now let's look at these. 64 is 8 squared. X to the 8th is the same thing as x to the 4th to the 2nd. And I wrote it that way because I want my exponent to match my index. So now I can say 8x to the 4th. Do I need absolute value? No, because my exponent was even. Anytime you raise a negative number to an even exponent, it'll always be positive. So I don't need absolute value on this one. On D, I'm looking for a cube root. So if I do factor tree, looking for groups of 3, so there's a group of 3, there's a group of 3. So I'm going to have one from each group, or I can rewrite that a couple different ways. Let's see, that's 8, and that's 8. Oh no, that's not helpful. I'm just going to keep it like that. 2 to the 3rd, 2 to the 3rd, x to the 3rd, and y to the 4th to the 3rd. And now I can cancel out my exponents and with my index. So this, I'm going to get 2, 2, x to the 3rd, y to the 4th. But 2 times 2 is 4. And I get that. And again, I do not need absolute value on that one because I had an odd index. Let's try these guys. 6th root of x to the 6th. Well, those two things cancel each other out, so I just get x. Do I need absolute value? Yes, because that's even, and the exponent here is odd. So even index odd exponent means you have to have absolute value. Over here, what was the 5th root of 243? Did we figure that one out already? I feel like I'm repeating myself on these questions. 243, that was 381, that was 9 and 9. Yep, we've already done this one. So that's 3 to the 5th, x to the 3rd to the 5th. And if I'm doing the 5th root, then I get 3x to the 3rd. No absolute value needed because I had an odd index. Moving over here. 8th root, that's x to the 8th. I'm going to rewrite this one as y squared to the 8th. The 8th root of x to the 8th is just 8. The 8th root of y squared to the 8th is y squared. Do I need absolute value? Yes. This is even, and this one is odd, and that's the only one that you need to put absolute value around. Don't put it around the y squared because anytime you square a negative, it becomes positive anyway. So you only need the absolute value on the variable that had the odd exponent. Okay, how many more do I have? Because I feel like I'm giving you way too many. Okay, we've just got 4 more. Leave answer in simplest radical form. Okay, so 18 is not a perfect square, so I'm going to have to do some simplifying. And p to the 3rd is not a perfect square either, so I'm going to rewrite this as 3 squared times 2, and I'm going to separate the p to be p squared p, because those two things multiply together to be p to the 3rd. Now, I can take the square root of this and the square root of this, but the 2 and the p are going to have to stay underneath. So I'm going to have 3p square root of 2p. Do I need absolute value? Yes, because I have an even index, which is 2, and this one has an odd exponent. And now that one's finished. Over here, 150 is not a perfect square, but I'm going to make a factor tree. So that's going to be 15 times 10, 5 times 2, 3 times 5. Oh, wow. Okay. Square root. Do I have a pair of anything? I have a pair of 5s. So I'm going to rewrite that as 5 squared. And then the 3 and the 2 don't have partners, so I'm going to multiply those back together. And then n squared. And n squared is a perfect square. So now I can take the square root of that, and I get 5n. But I can't take the square root of 6, so it stays there. Do I need absolute value? Yes, because the index is even, the exponent is odd. Okay, 2 more, and we'll be finished. 6th root of x to the 4th. I don't know what a 6th root of 384 is, so I'm going to make a factor tree. I know it's divisible by 2 because it's an even number, so let's see. 384 divided